everybody. That's right, shaky cell phone cam video. Actually, I have it on a stand, so it's not so shaky, but I'm at like 15% battery, so I have to talk quickly. Like, that's different than usual. Now, I'm filming this because I have 5 minutes between these 3 different jobs that I am working around where I can have all my ventilation and my fans and the printers and the machines and all that off. So I'm going to squirt this out, then I'm going to start another job, and when that's finished, I'm going to do the dictation for this port. So these days, ever since companies like, Creality have come in and sort of cleaned up that bottom end of printers, we don't have things that are like, 3D printing plastic spewing death traps anymore. But I sort of sometimes miss the days when you could grab a printer and be like, oh wow, this is an abomination, look at all the things wrong, and then you could just go straight up Gordon Ramsay on it. So what we're doing is I grabbed, and I didn't even know what the name of this was when I ordered it because it went on there. Apparently it's a Kingroon KP3 or KP3S or something of that sort, which at the time came to the priestly sum of $89 plus shipping from overseas, slow boat shipping. We're just going to do the unboxing, and I'm going to tear it down and look at the components and the fit and the design and all that sort of thing. Go through it bit by bit and let you know what I think. And then when I get time to put it back together and do some actual printing with it, then we'll do the next part, which will be the printing and the firmware and all that. And then maybe there will be a third part in the video where I just go through and fix some of the problems and roll some new firmware. I don't know. We'll see how far that gets, and we'll see how the actual printing does. I guess the printer itself will dictate whether there's another part. Spoiler alert, it's not that bad. Also, spoiler alert, it's not great, but I was thinking this was going to be a straight up Gordon Ramsay, "What are you, an idiot sandwich" type of a deal, but it didn't end up being that way. But without further ado, the Kingroon KP3. This is what this little fella looks like. Maybe, sort of, not really though. But regardless, it comes in a couple different options that put it anywhere from between $89 and $150. I think this is the most expensive place end version you can find for this one, and that's buying it through Amazon Prime and buying it with the linear rails and the direct extruder. Before the trolls come out and start making snarky comments, I know that I'm a few months behind on this. Like I said, I've been really busy, haven't had time to poke around the forums and see what the new cool printers are for the kids. And I know there's a ton of videos out already. I have seen the thumbnails, but I have not actually watched a single video on this thing. So I like to go into this blind, so there's no expectations or preconceived notions, and then see what I pick up on. So anyway, the things that attracted me to it were the linear rails and the direct extruder. I mean, that's a big deal for under $150. Now, the problem with this is, bear in mind through this entire thing, you're competing with buying an Ender for practically the same price, which is a well-trod design. There's a ton of support. You can find videos about it everywhere. There's modification forums. You can go to Reddit or Facebook or Discord or whatever. So let's see what this may offer that the base model Ender does not. Just rattling this off from their standard spec sheet: TPU capable DD extruder, so direct drive flexible capable extruder, that's a claim there. Micro SD and USB-A support, the big type of USB cable that a lot of people say they like better than the little ones, even though I tend to disagree sometimes. 110 degrees Celsius capable hot bed, a hot end that's capable of up to 260 degrees Celsius. Anytime you see 260, you know that means it's probably Teflon sleeve, but we'll find out about that. 180 millimeter cubic print area, print resume after power out function. It has a 32-bit MKS Robin variant board in there with a healthy amount of storage. We'll talk about that in a little bit. TMC 2225 drivers, not sure if they are run in UART mode or in regular standalone mode. We won't find that out to the next video when I can actually check out the electronic functions. Flexible magnetic print surface, we will have to see also in the next video if that is a surface that can take the 110 degrees Celsius heat, or if it's going to, give up the ghost there. Enclosed electronics, safe isolated power supply unit, dual shaped guideways, aka linear rail, color touchscreen, open source firmware, 24-volt power supply, and it's mostly pre-assembled. Standard looking box, Kingroon product number KP3, so this is what's marked on the side of the one that I got in particular. Is it just me, or does Kingroon sound like the unofficial nickname of like a Kiwi rugby team, like "Hey come the Kingroons," and then they dance a haka or something, but whatever. packaging is pretty good. They've gotten real good about packing these up these days. We're a long way off from like those old ANET printers that were basically just bags of bolts tossed in a box. We also have just your standard little, probably PLA test filament. That's fine. I have so many little vacuum sealed bags of test filament around. An actual printed manual, which is nice. I mean, basically everybody can open a PDF these days, but it's kind of nice just having a printed manual here. And it looks like this is actually specific to this model printer. The lead screw comes in this separate container right here, so it doesn't get damaged. Unfortunately, it's not straight, but we'll get into that a little bit later. Your goodie box right here includes all the tools that you're going to need for putting this together, and most of the tools you need for maintenance. So we have, for some reason, a spare thermistor for the bed. I'll find out what that's all about, I guess. We have clippers like we do on everything else, a very short USB cable, but whatever. Since it's standard USB-A, you should have something that fits. A spare length of Teflon tubing, I guess, if you want to switch to Bowden style. Now, unfortunately, just taking a look at this, I don't know if you can see, it is some of the cheapy blue Capricorn look-alike knockoff stuff that's a little bit off-center in a tubing. Sometimes that doesn't matter, but just be aware. But this is the direct drive printer, so that's neither here nor there. And finally, we have our power supply. This is a 24 volt 360 supply, just like on the Ender. We have a plug that is 2 connectors, and then we have a 3 connector plug going in. So hopefully that means safety ground to the chassis of the power supply and then isolated output to the printer. We shall see. And then basically the rest of the chassis of the printer, the rest of the frame of the printer, this is all put together for us. Really, all we have to do is slide the Z-axis into the base plate and we should be ready to rock and roll. This is a steel chassis, though I have expected this to be plastic. I wasn't sure, and it looks like we just bolt the Z-axis in through the bottom. Now, we're going to have to see what the support looks like inside because it's completely dependent on the rigidity of the bottom plate. The Y-axis motor is no name. It's on a bracket, but it doesn't appear to be adjustable, so we'll have to see if there's a tension adjustment inside. Flexible coupler for the Z-axis lead screw, and then we do indeed have linear rail. It appears to be mounted directly to the chassis. We'll have to see what kind of support there is underneath. Seems fairly rigid, just a little crunchy. We'll look at that more in a little bit. Magnetic build plate, again in the next video we'll have to see if that'll take 110 degrees as claimed on the tin. And moving on to the other assembly, you can see the direct extruder right there. Again, no names on the motor, so not sure what's going on there. We'll see if we can pick those up before the next video. We have, for the Z-axis, a sandwich design going on here. That's very nice. If they have their machining properly, that adds some rigidity to it, so we'll see. Looks like they put the lead nut upside down, and it doesn't appear to have a whole lot of adjustment. So hopefully we're not off-centered and we don't have to worry about that, but we shall see. And we have a pretty good view of the X-axis, and there does not appear to be any tension adjustment, which is quite unfortunate. Now, they did include all the tools we need for a teardown, but I do highly recommend you get a couple things. One of them will change your life are these T-handled Allen wrenches. I'll put a link to these in the video description below. But I always try to use the stuff they included, so on with the crappy little chromed POSs. Oh boy, first peek at electronics. First thing I noticed, be careful. This cable is not very long and it pops right off the motherboard somewhere. Thankfully that was not soldered, it's just clipped. This is a Kingroon branded, apparently MKS Robin Mini board, and it has socketable steppers, which I always like, thank you very much. Now let's yoink one out and verify that it is actually a Trinamic stepper, and it does appear to be. Right here it says TMC2225. There's not a whole lot of info on these, but they are a part of the TMC 22XX series, so we expect them to behave like the 2208s or something like that. As for the board itself, it does appear to be a maker-based board based around an STM32 chip. They actually used an STM32 F103VE. Now the VE part means that it has 512K of user programmable flash, which is very nice because we are increasing in the size of our firmware these days and the features that we need. 64K of RAM, also very nice. And it was at this point that my Kingroon sticker fell off, so just be aware that's a quick release sticker. Anyway, my greatest fears for the Y-axis, they were confirmed. Unfortunately, we have a floppy belt. It's held in place by zip ties, and we have no adjustment mechanism. That's quite unfortunate. Second order of business is to make sure the wiring is safe, so I'm going to pull out all of these and cap them where necessary with these little crimp caps. I get a lot of use out of this. I'll drop a link in the video description for that as well. Just a heads up for polarized connectors, I noticed that there are no markers on the top of the molded blocks, so just go ahead and take a little Sharpie and put a plus and minus on there so you don't confuse yourself. Now the safety hazard moment of truth. How did they connect these high current wires? Did they do it properly? Well, no, they absolutely did not. What they did here, and I've been banging this gong for years, they tinned the ends of the high current connectors. With the Euro style rising pin blocks, you can't do this because of thermal cycling. It increases contact resistance, yada yada yada. You have mechanical problems. I thought I screamed enough about this during the ramps era, but apparently I did not. So I'm going to give myself some extra slack here, cut off the tinned part, and then cap these and land them. I really wish manufacturers get on a ball with this, but whatever, we'll deal with it on a case-by-case basis, I suppose. So now I'm going to determine the grounding scheme, just for reference purposes. I'm checking that the chassis and the electronics grounds are not tied together. So sometimes we have a board that floats, sometimes we have it tied to the chassis. It really depends on how the board is designed. This one is actually floating. Usually when you have a USB output connection to a computer, it's floating, so that's fine. But that only matters if you also have a power supply with an isolated secondary, which hopefully we do, and that they didn't tie the safety ground to the output ground. Well, it wouldn't be a ground, it would be a minus, I suppose. So those are isolated. I just confirmed here. Now we get to see if the safety ground is tied to the chassis of the power supply, and right here you can see that it is. We have very low impedance from our third prong to our power supply, so that's good. Now I'm going to check if there is conformal coating on this, and there is. You see that we have no resistance, and then between the ground and the screws we do have continuity, so there you go. So let's just go ahead and get her together. Now it appears that the only thing you have to worry about as far as getting the mechanics together is these two little screws that go onto the bottom. So of course 50% of what I have to do was screwed up because my screw was messed up. But they include spares, which is very nice to see, so I just whipped out another one of the included bolts and bolted it back together. Note, I did not use the split lock washers that were included. I actually use thread locking compound, just a blue Loctite, so that's a matter of preference. Now, since we don't have a lead screw installed, we can move the Z-axis around very freely, except that it does not move very freely. So here's our first kinematics problem. A, the Z-axis is very tight, and B, it's very rough. So I tried messing around with a concentric screw. I could get it loosened somewhat, but it was still tight and it was still rough. It appears that it was over-tightened and forced on, so we do unfortunately have flat spots on our wheels, and we'll have to pull this apart and see what's going on. User note, if you have to do this at home, you're going to have to snap these two little zip ties right here. So make sure you have a couple spares around, and then pull the bumper off the top and it just slides out, which is nice. And these come apart like any other open build style V-slot wheels. Shout out to my Jersey bros over there. Unfortunately, these are not genuine open build wheels, and I didn't expect them to be, but the manufacturing tolerance is not very good, and you can see right here that the wheel spins around the bearing, so that's not going to live a long and glorious life. Fortunately for me, I do have pretty nice wheels in one of my barrels. Oh crap here. So I'm just going to whip out a new one, stick that on the adjustment wheel here. I'll leave all the other ones in place. But that's something to bear in mind. Maybe pick up a couple spare wheels. That's generally a good idea to have spare moving parts regardless. So let's go ahead and look at the Z-axis nut, because this is an area that can be a lot of problems if it's not implemented well. This is, like many of these low-end printers, a brass nut, not an oil-impregnated bronze nut. So it is not technically self-lubricating, so to speak. Also, for the sake of alignment adjustment, I am going to pull it out and flip it around the other way so that the gantry is resting on the flange of the nut, not the gantry pulling down against the bolts. That's just because you want to be able to align that a little bit if our Z-axis motor is not perfectly in line with our Z-axis threaded rod. Now, unfortunately, they didn't offer a lot of adjustment here. We want this nut to have a little bit of play, so I'm going to tweak this Z-axis until it moves smoothly so that we can then put our threaded rod in and try to align it as best as possible. So disconnect the motor if you can, just to prevent any back EMF from frying anything on our board. You never know. Then we're going to loosen the lead screw nut on the gantry so that we have a little bit of lateral play. Then insert our lead screw and tighten that down into the Z coupling. Make sure the Z coupling set screws are tight on both the motor and the threaded rod itself. Then you're going to run the gantry up and down by hand to allow the lead screw nut to center itself where it would naturally be. Hopefully there's not too much variance between top and the bottom. But if there is variance, run it down close to the bottom but not all the way down, and that's where you're going to use. Then tighten everything down, run it back up and down, check, and repeat if necessary. Adding a little lubrication is not a bad idea either. You could just use a light machine oil or anything that doesn't attract a lot of dust and grease. Don't use something like a WD-40 that's going to mostly evaporate and then just leave a mineral oil film behind. Teflon impregnated synthetic oils like Triflow are probably okay as well, and you could even use like what is that that everybody, a Super Lube is probably fine. I've used that on lead screws and it's okay. It gets a little bit gross after a while, but it doesn't jam anything up. So hopefully we have no binding, which means no Z-wobble, which means no goofy layers by the end of this. The problem is, as you can see right here, our lead screw is a little bit bent. Now that's not the end of the world since we're only single constrained on this at the bottom. It just means we have to make sure we allow this to be aligned as best as possible, and then don't do any of those goofy things where you print up a bearing to stick on the top, because you're just going to get the whipping action throwing your Z-axis around more if you just leave the one side unconstrained. I have a video about that. You can go back and look it up. I believe that's in the ball bearing trick video, and I thought about preemptively doing the ball bearing trick on this Z-axis just because my threaded rod is so far off, but we'll see how it prints in the next video, and then we'll go back and do that if necessary. Oh boy, we're 17 minutes in already, and I haven't even gotten to the extruder yet. So let's go through and bang through some of the other possible kinematic issues that I had with my machine, and then we'll get on to that. As I mentioned before, the linear rails are a little bit crunchy, so these do us no good if they're garbage. We'll have to see if that affects the print, but here's what they sound like. Hopefully you can hear this all right. So yeah, that's pretty crunchy and gross. Like I said, we'll have to see how that affects printing. I'm tempted to disassemble those and see what's in there, making it crunchy, but I want to get some test prints out first before I go pulling it apart. So we'll see about that. Another area of potential problem for longevity I've seen is in strain relief for the wiring. This is a big one and it's fairly simple to fix, but not many people are doing it. I'll show you videos of a couple different areas where that's a problem, mostly on something that has a lot of linear movement like the bed. If we can't keep that cable from dancing around and keep the strain off of the solder joint of those wires, those are just going to pop off and short out. There are similar issues, though not quite as extreme, on the gantry as well. This is probably easily dealt with because I have mounting points for zip ties. And here's another thing I mentioned earlier in the video that I promised I would get to, and that's the belt tension. There's no provision for tensioning the belt, and the belts are only hold on with zip ties. I don't like this arrangement very much at all. But there's not a way to properly address it with the hardware that's included, maybe some mods or something like that, but we'll have to see how bad it is in printing. And again, that goes for the Y-axis as well. As you saw when I had the bottom plate off, that belt is also a little loose, also held on with zip ties, and also has no way of tensioning it. Now, a real cheap and easy way for these manufacturers to do this is to use a sliding motor mount. I mean, I just don't know why they don't do something just that simple. It's not great for setting the tension, but at least it's good for getting the slack out. And as I mentioned before, over the break in quotes during the quarantine, I did a bunch of tests with belt tension on the Ender, which hopefully I'll have time to get that out, and found, spoiler alert-ish, that the best tension tends to be manufacturer specification or a little bit tighter. Surprise, surprise. Biggest issue of all is that this covering for the LCD makes for the least sexy peel I've ever done. Forget it. It's garbage. Send the whole thing back. But now let's get into what I consider to be kind of the heart of the 3D printer, and the thing you most want to nail, which is the extruder. Without the extruder, you just have basically a three-dimensional plotter. It's putting that extruder on there that turns it into a 3D printer, and it's the most important thing to nail. It's also what's going to dictate not just the quality of your print, but the speed of your print, the types of materials you could print in, how much ringing you're going to have, etc., etc. And as I mentioned, I know I'm a couple months late and I haven't checked out any of the body of work on this printer, so forgive me if some of this is covered, but this is just my cold take on the extruder, and I find it a little bit wonky. Now, it's not just that it has some rough edges that you could fix, some modifications that you can make, but the entire design is a little bit confusing from the get-go, and let's just walk through it one piece at a time. First off, there's no tension adjustment for the arm on here. This is becoming more and more common these days, and it's extremely important. Now, you could go ahead and stack washers underneath and do all kinds of goofy modifications to set the tension to a particular level, but having it adjustable will save you a lot of agony in the long run when you get to tricky prints. Second problem is this brass feeder gear right here. Now, it's probably adequate for a while, depending on what types of filament you're using, but you don't have a lot of longevity with brass because it's not very hard, and those teeth are not very sharp, so you're going to have slippage. Now, again, that depends on the temperatures, the speeds, the types of materials, but just something to be aware of. If you want, what I have found is if you're going to be using a single side feeder like this, the best gear on the market, for me anyway, has been this guy from Robot Dig. They're super cheap. Used to be able to get them on Amazon. I don't think you can anymore, but I'll take a look and see if I can link something down in the video description. I think there's probably feeder gears on the market that are more smooth in terms of quality, but these guys, if you're just trying to push filament through as hard as you can, here you go. So you can see right here what a number it's done on some stubborn filament. But regardless, this is a picture of this exact same feeder on my ender, and you can see that A, I've changed the feeder out, and B, I drilled through the tension arm so that I could have a little bit of adjustment there. And that was actually an emergency replacement for one of these dual feeder geared extruder jobbies that print great, but they eat themselves to death within a couple months. So I'll have a little video on that coming up. But regardless, the feeder on this guy, yeah, no adjustment, and the brass nut and a little bit of play in the arm, but that's inconsequential compared to the other two. In terms of the overall design, what I would call this, if you were to compare it to like a MakerBot Mark series extruder, I don't know, maybe Mark 9, maybe Mark 8. 8.75, Mark 9.5. It doesn't conform to all of the different parameters as far as the MakerBot Mark 9, but it does compare to some. So it's not a Mark 8 like this, which has the heatsink built into the cold end feeder, and it's not a Mark 10, which has this style of tension set instead of threaded 7mm drilled hot end throat. But rather it's kind of in that period of transition where the kind of, what was it called, the MakerBot Smart Extruder, whatever that disaster of an extruder was that they appear to have taken down to cover their tracks. Thank you for not letting the community learn from your mistakes, but regardless, yeah, maybe Mark 9-ish is the best way to explain it. So since this is a Mark 9-ish extruder, we know what to expect. A 6mm threaded heat break that's 40mm long, probably PTFE sleeved inside, and this style has a long transition zone as opposed to the short transition melt zone that's been adopted by like the E3D extruders and that type of deal. But I couldn't be sure if it were PTFE sleeved or not, so I decided to go ahead and pull it apart, which was a little bit difficult. That does not bode well for filament jams, but regardless, we can see that the heat break is indeed one big long threaded piece that extends from the feeder all the way down to the heat block. And pulling that apart, we can see that it is indeed PTFE sleeved. And you can also see that mine was mangled AF. I don't know what the heck happened in here, but I'm just going to go ahead and replace that. And with these sleeved heat breaks, I don't really use these anymore, but when you have this, consider this inner sleeve consumable. Like, that's going to go quickly, probably before any of your other parts. So if you are going to swap your nozzle, or if your nozzle wears out, you should probably go ahead and just do this sleeve at the same time. I mean, the heat breaks themselves aren't that expensive to buy, but you can easily replace this, as I do here, by just taking a little piece of, you know, the Bowden Teflon tubing and cutting it to the proper length. Oh, and a quick tip for getting that piece of tubing out of there, especially if it's mangled, just take a drywall screw, one of these small ones, thread it in a little bit. You don't even have to mangle it. Thread it in a little bit, pull it right out. Boom. Next problem we have is the heat block itself. It is both undersized and exposed. It's fairly cheap and easy to go ahead and put some of the like hot end cotton on there, or maybe find a silicone sleeve that fits on top of it. I'm not sure if they have any size to these small blocks. I'm not positive about that, but this should definitely be covered up, especially since you see the radiator cooler for the heat break is going to be blowing right down onto it. And mostly that's going to be an issue with consistency and getting the hot end to get to temperature and stay to temperature, particularly in the heat up phase. If you're heating the bed as well, you might get some thermal runaway warnings, in addition to a lot of erratic temperature drift. Also, if you look up any data sheet for any cartridge heater for any industry, all the top no-nos relate to getting the cartridge to fit properly in a block that you're installing it in. So we can see here that not only is the tolerance sloppy, but it also extends out past the sides of the block. So both of those are no-nos. You can shim this with aluminum or copper foil until you get a tighter fit, which is recommended, but it's actually more recommended to just get a block that fits a proper heater. Like, this is not a block that I want to use. It's also slightly undersized, but it's probably okay for a while. I'm probably going to shim mine before I do any printing though. Next, the cooling fan for like PLA and that sort of thing. It's a single side design like this with a small axial fan. These are not optimal, but it's kind of like the old Ultimaker designs that they ditched a little while back. This is easily fixable though, because it appears to just bolt off with these two screws. So you could basically bolt on whatever you want there and it'll be fine. Easy peasy mods. All right, coming up on a half an hour, so I'm gonna have to call it here. I really have to get back to work, and this is gonna take me hours to edit tonight. So this will sit on the shelf in its partially disassembled state until I have time to get back to it, and then we'll do an actual printing video. If you have any specific questions, let me know in the comments in the video description. I'll try to read those as best I can. I know I'm falling way behind, but maybe we'll get to a Q&A sometime soon, since we're rolled over into a new month, and I usually try to do those at the beginning of the month. TLDR. First off, we have tinned power wires and poor strain relief. That falls into the electronics section. The tinned power wires, that's a safety issue, as is the strain relief, because eventually those will snap themselves away from the PC board, particularly on the Y-axis bed heater, and they're going to short out or zap something. So that's something you want to take care of. As far as the tinned power wires, those are going to have to be cut back about 1 centimeter, stripped, and then preferably capped with ferrules before you land them again, but you don't necessarily have to cap them with ferrules. So as far as the kinematics on the gantry, we had that one borked wheel. The adjustment wheel was borked, so I replaced that with a genuine OpenBuilds wheel. I suggest you do the same if you have the problems. Better that than trying various import wheels and seeing which ones happen to fit tolerance. You'll save yourself a lot of frustration. Just go straight to OpenBuilds and buy one or two. Then we had the bent lead screw. Again, if you want to replace that with a straight one while you're at OpenBuilds, I have never ever had a problem with the lead screws from OpenBuilds, and I have them on 3 or 4 printers in my room currently. Also, we had the crunchy linear rail bearings on the Y-axis, particularly. The X-axis seemed okay. We'll see if that affects the print, and then after I get some prints out, I will see about taking that apart, looking at the race with a microscope, seeing if there's any like sand, metal filings. I don't know what's crunching in there, but it definitely didn't sound good. Now, onto the less vital parts. We didn't have any belt tensioners, and we didn't have any lead screw nut adjustment, so that's a little goofy. There was a bit amount of float on the lead screw nut, but you know, not enough to keep it from binding if you had something that's not particularly centered. However, since our motor isn't adjustable, everything technically should be centered out of the box if you didn't have something that's physically bent as far as your X-axis or Z-axis gantry. So moving on to the extruder, you might get one that's okay, you might not. Your printer might print fine out of the box for a while, but since there's no adjustment and you have the soft screw and the PTFE sleeving that might be a little bit it's probably not going to print like it did out of the box forever. I would actually say just go ahead and print with it as is for a while. There's no particular safety issues right off the bat, and then as things go goofy, just replace them as needed. What I'm referring to is the PTFE heat break sleeving. That was bad out of the box on mine, and remember that's a consumable, so you might want to get yourself some razor blades and sleeving. Actually, they have that blue sleeve that comes with it. Maybe that's what it's for, who knows. We also had the meh parts cooling fan. That's fine if you're printing in something like ABS. If you're printing a little bit thicker layers or faster in like PLA, you're going to need better heating, but again, that bolts right off, so an easy mod. Unconstrained cooling fan flow, that's going to affect your ABS prints as well. Just like on the Ender, we might have a little bit of a bleed out of the bottom, and then you get problems with warpage. The lack of heat block insulation, that's a really cheap and quick fix that I can't imagine why they overlooked that out of the factory, but you could always hop onto your favorite 3D printing parts manufacturer or just Amazon or eBay. Grab some of the block cotton and put that on there, or see if there's a silicone sleeve that'll fit on that particular block. I'll take a peek around, and if I find one, I'll put it in the video description below. The questionable block is another one. The tolerances are real sloppy, and it's a tiny little block. It's not great, so if you're going to be replacing things in the future, think about getting a whole unit and replacing that block right off the bat. Also, no tension adjustment on the cold end means that you might get a little bit of slippage and under extrusion, and the brass feeder gear, that's going to wear out fairly quickly. Alright, thanks for sticking around. Sorry about the sparse video. Like I said, I got a lot of jobs going on. I got permission from at least one of them to talk about it, so maybe in a couple weeks when it's finished I can do a wrap-up, show you what I've been doing, and then get some video content out of it, because I haven't been able to do any of that sort of work. But until the next video, get out there and make something awesome. Oh yeah, I have to do the AutoCAD video too. Okay, CAD video incoming, hopefully soon. All right, bye.